In this video, we're going to look at quadratic equations, which arise very frequently both in mathematics and in the sciences. We'll touch upon how to recognize a quadratic equation and also a couple techniques for solving these kinds of important equations. Recall that a linear equation is any equation that can be put in the form ax plus b equals 0, where we assume that a is non-zero. In other words, a linear equation is one that is arrived at by taking a linear expression and setting it equal to 0. A quadratic equation, on the other hand, is an equation of the form ax squared plus bx plus c equals 0. In other words, it's an equation that can take the form of a quadratic expression being set equal to 0. And here we also assume that the constant a, the coefficient of x squared, is non-zero, since otherwise this equation would just turn into a linear one. So to give an example, this equation that we're looking at is, as we'll see, an example of a quadratic equation. Despite the fact that it has a lot of terms floating around, we can see that by trying to put it into standard form. So I might begin here by combining like terms. 10x minus 2x on the left-hand side gives me 8x minus 3. And that will have to equal, let me combine the x squared terms, minus x squared plus 1 minus x. Moving everything on the right-hand side over to the left-hand side now gives us x squared plus 9x minus 4 equals 0. And this is indeed the standard form of a general quadratic equation. Indeed, we could say that this is a quadratic equation with a equal to 1, b equal to 9, and c equal to negative 4. Now, quadratic equations happen to model all sorts of phenomena. One classic example from physics involves projectile motion. So imagine, for instance, that you take a ball and decide to throw it straight up in the air. What you can do is try to measure the height of the ball at a given time. As it moves all the way up to the top of its trajectory before coming back down. And it turns out that this kind of motion, this sort of projectile motion, is modeled precisely by a quadratic expression. Although we won't try to tackle the problem of the moving ball in this video, the point is that it is very useful to be able to solve quadratic equations. And just to remind you, what that means is that we want to find all values of x that make a given quadratic equation true. Let's take a look at an example, and notice that this particular quadratic equation has a very simple form. That is to say, it has no x term. The coefficient of x, which we call b, is equal to 0 here. And what that means is that we can actually solve this particular quadratic equation directly. And what I'll do is begin by subtracting, or rather adding, 8 to both sides of the equation to give 2x squared equals 8. Then I'll divide both sides by 2 to obtain x squared equals 4. And now we simply need to think about the set of all numbers x, which have the property that when squared, they give us 4. And that means that x will have to equal plus or minus radical 4, so that x equals 2 or negative 2. This is the solution of this particular quadratic equation. X can take on two values. It can be positive 2 or negative 2. Other quadratic equations require a bit more work to solve. So this particular quadratic equation has the property that there is an x term present, right? The coefficient of x is non-zero. And that means that the same approach that we used with the previous example will not work here. What we can do to solve this quadratic equation, however, is employ another very useful and important technique, and that's the technique of factoring. So let's begin here by trying to factor the quadratic expression in the left-hand side of our equation. I'm going to set up a couple parentheses here, and try to look for two numbers whose product is negative 14 and whose sum is 5. And if you think for a little bit, you should see that the numbers negative 2 and positive 7 do the trick. So what's the benefit of factoring? Well, by factoring the quadratic expression, we can now see that the product of two things, namely x minus 2 and x plus 7, is supposed to equal 0. And it's a basic but very important mathematical fact that whenever two things, a and b, are such that their product is equal to 0, then it must be the case that a is equal to 0 or that b is equal to 0, right? The only way the product of two things can be 0 is if one of the two factors is 0. And this insight is already enough to write down the solution. We now know that our expression can equal 0 either if x minus 2 is equal to 0, and that occurs precisely when x equals 2, or when x plus 7 is equal to 0, and that occurs precisely when x equals negative 7. So the two solutions of this quadratic equation are x equals 2 and x equals negative 7. Here's another example that's a bit trickier, but that involves the same basic reasoning. We are once again going to try to solve this quadratic equation by factoring the left-hand side. This time, the coefficient of x is not equal to 1, so our factors will be slightly more complicated in form. But basically, by thinking about the factors of the number 6 and also the factors of the number negative 5, we can see that this will factor as 2x minus 1 times 3x plus 5. And now, once again, to write down the solution of the quadratic equation, we just have to use the fact that our quadratic equation will be, or our quadratic expression will be 0 precisely when 2x minus 1 equals 0. That happens exactly when x is equal to 1/2. Or when the factor 3x plus 5 is equal to 0. And that happens exactly when x is equal to negative 5/3. So these are the two solutions of this quadratic equation. In summary, we have looked at two different techniques for solving quadratic equations. Let's quickly review what they were. On the one hand, if the quadratic equation happens to have the particularly simple form ax squared plus c equals 0 with no x term, then the equation can be solved directly, and the solutions will be x equals plus or minus the square root of minus c over a. By the way, that's not a formula you need to worry about memorizing. It's simply the answer that you arrive at by performing basic manipulations. On the other hand, we learned about the technique of factoring. So if you have a quadratic equation that factors nicely, for instance, that factors as a product x minus alpha times x minus beta, then all you need to do is set each factor equal to 0 and solve for x. So the solutions here would be x equals alpha and x equals beta. One final thing to say is that it is not always possible, or at least not always easy, to apply these two techniques for solving quadratic equations. Indeed, some quadratic equations are rather more difficult, and it would be nice if there were some general formula that gave us the solution of a quadratic equation in all possible cases. It turns out that there is such a formula, but that's a topic for another video.